Hey everyone, my name is Ronak, back with another video. And in this video, we are going to learn about a new technique known as two pointers. So this is the second video in the series of the data structure and algorithms that I'm covering. So let's get started. So in the last video, we actually saw the basics of array. But I was thinking about moving on to the another data structure. But right before that, a thing struck to me that we have to cover some or the other concepts of optimizing your code in a certain angle with the arrays itself, because many questions will be asked from the arrays itself. A very strong and conceptual understanding of array is going to get you far away in the process of the interviews. So let us get started. So let us try to understand a problem. Let us assume that you have an input array and it is a random array. After that, you also have a target element. Let's say n. So your goal is to search for the two elements in that array in such a way that their addition is equal to target. Now let us look at how you are going to approach this kind of a problem, which is very straightforward. You have to approach this kind of a problem. The way you approach this kind of problem is that you will go through a series of, let's say, for loop. And there will be, let's say, one pointer. Then there will be another for loop with one more pointer, let's say j, and this one, let's say I. And these two will be compared till the end of the process, which is basically till the end of the array, and they are going to add. So addition will be happening and the checking with the target will be done. And let us only return boolean. So let us say true. So this is the process. Now let us actually write some code for this. Okay, so let us make a file known as concept.py. Okay, and now here let us start with let's say making a function. So we have to focus on, let's say, two specific occurrences of the numbers. So let's say summation occurrence, something like that. Okay, and this is going to take an input array, which is essentially going to be a list in Python, and there will be a target element, which is basically int, and then it will return a boolean. Okay, so starting with that, we are first going to make a for loop for I in the range of the length of my array, input array. So I points to one number. Then for j in the range of, let's say, length of my array, something like that. And later on, let's say, if after accessing the ith element and adding it with my jth element, whether it is equal to the target. If so, I am, let's say, going to return true, which is very trivial. And another condition states that if the array of I plus array of j is essentially greater than, let's say, the target element, so we will return false. Okay, and in the outside of the condition, we can say return false. Okay, so now let's make an entry point for this, and now let us try to print this function. So right before that, let's make an array of let's say 1 3 okay 1 3 5 and let's say 7 and 9 and 11, something like that. And let's say the target is going to be, let's say, 8. Okay, I'm sorry, target, let's say, going to be 8. And now I'm just going to print this. So summation occurrence takes array and my target. Okay, now let us try to run this. So over here in the two pointers, and let's say pi const.py, it says true because the element 3 and 5 are basically giving you the 8. If we take something out of the points, let's say 90, something like that, this is not practically possible, so it will say false. We have it. Now, if we check the performance time of this, okay. So let's say I want to check the time of the execution. So from time, let's say import the performance counter, and let's say when the function is called, I want to perform something on it. So let's say we will actually try to separate this out also. So let's say the Boolean outcome is there. So here I'll say, let's say start and call the performance counter, and then let's say end over here with the performance counter once again. And now let me print, let's say the time taken by the function is end minus start. Okay, and now let us try to run this, and we have it. So this is the time that is basically taken by our function. Now if you have a little bit of notion about the time complexity, this particular function works in order of n square because you have two for loops. So is there a way, or is there an optimized method with which you can basically reduce the time for this? Because whenever you are competing with the other people who actually are in the interview process, you have to come up with an efficient solution. This is the first thing. And since I was thinking about moving on to the another data structure, my personal belief is that try to master array. Okay, because there are many more concepts that are going to come in the near future, which is something like sliding window and cadence algorithm. But I want you to understand the underlying basis of why we are actually doing this. Our task is to optimize the time taken by the function. If you are a person A and there is a person B competing with you for an interview, your duty should be to create a more efficient solution than the other person. That's it. If my code runs better than the other person, I'm going to nail the job. So that is the reality of this. So is there a way to do this in the linear time? Okay. So is there a way to do this in linear time? Is there a way to do this in order of n, which is essentially your linear time? Well, the concept is known as two pointers, where you have specifically two pointers in an array. Okay, so let's say this is my array. Now essentially the for loop was basically assigning something over here and again over here, and every single checking was using the two for loops. Instead, we are going to work with two independent pointers pointed at certain, let's say, distance, and when a function is evoked with the condition, I want to shift these pointers. Okay, so I want to shift the pointers. So this is my goal, shifting the pointer. So this happens in a linear time. When I will show you the code, you will get a better intuition of this. So let us take an example. Let's say the example that we have already taken earlier, okay, which was in the code implementation. So let us take the code example, and the values were basically something like 1, 3, 5, and let's say 7, 9, and 11. Okay, so this is an array. Now I will place a pointer over here in the start and a pointer over here in the end. And now I will run a condition such as a while loop, where I want to check that these two pointers do not cross each other. Okay, so let us assume this is the left pointer, this is the right pointer. So I will check this condition while L is like less than R. Once they cross, we are going to break out of the loop. So this happens in a linear time. Okay, so let us say my target is 8. In such a scenario, first it will check that 1 plus 11 is equal to 12. Does it reach the target? No. So the target is essentially greater than, the computed value. Computed value is basically greater than your target. In such a scenario, I'm going to shift pointer. So now this points to 9. Get it? Okay, we will shift this pointer. Again, we are going to run the condition. So 1 plus 9 over here is going to give 10. Again, this is happening. Computed value is greater than the target. Again, I'm going to shift it over here. And now finally, I will check 1 plus 7, which is 8. It happens. Okay, so it is equal to my target. In such a scenario, we are going to break out of the loop. So this is the way it works, and it works in linear time. You don't have to specifically use 2 for loops and keep on going till the end of the line. So now let us write a code for that. So let us say df and let's say 2 pointers. I'm just going to name our function as 2 pointers, which accepts an array, which is a list. Later on, there will be a target, which is int, and then we will have bool. Now I will make, let's say, one left pointer. You can also call it start or end. I usually call it start and end. Start is from 0 and end is the end of the array. So essentially it is length of array minus 1. Now while the start is less than end, I want to perform something. In such a scenario, I'm going to say again, if let's say the array of start plus the array of end is, let's say, equal to target, I want to return true, because I am just taking a boolean response for now. We will look at some of the problems like this. Else if the array of the start plus the array of the end, if it is like greater than the target. Okay, so when the computed value that we actually saw over here, okay, this one, this particular block, let me highlight it, this one, the computed value when it is greater than target, you have to do something. Okay, in such a scenario, you are going to shift your end pointer to the left. Okay, so I will say end minus 1. So this is basically end is equal to end minus 1. A more technical way of saying this is end minus is equal to 1. Else, I am going to shift the start pointer. So start is going to be incremented, because in an array when you move to the right side, you will have to add the pointer. Okay, so by plus 1, and in the end actually moves to the left side, so it is minus 1. Okay, so this is our function, and let us say return false as the base condition. Okay, so the code is ready. Now let me copy this itself, and we will now test it. Okay, and instead of let's say summation occurrence, I am going to say 2 pointers. And we have it. Now it is time to run. Okay, so I'll get rid of this. Okay, now if you see, check the time taken by the function. Okay, so the let us also make change over here. So the time taken by, let's say, summation occurrence, and this is the time taken by, let's say, the 2 pointers. If you see the time, every time you run it, it is going to be less. So this is an efficient type of method to solve the problem. Okay, so that is what I wanted to convey. Now we're going to solve some Leetcode problems with this. So let us look at some Leetcode problems. So we will take 2 easy problems and 1 medium problem to understand the concept. Okay, so all of this code and also this whiteboard stuff will be there in your GitHub repo in the link below. Okay, so you can just visit that. Now let us start with the problems itself. So let us say problem 1. So I have handpicked some problems that actually use the concept of 2 pointers or 2 pointers. Okay, so first problem that we are going to take is valid anagram. Okay, so it is valid palindrome. Okay, and not valid anagram. So it is valid palindrome. So what the problem states, so if we see the problem, it actually says that there is a sentence, And when you turn that sentence, like you try to read it from the other side, it is also going to again give you this output. And it expects you to give, let's say, boolean, which is basically true or false. So palindrome is when the string is read from the other end, it is the same. So now how we are going to work this using two pointers. The usual way would be to use two for loops, but now we are going to see using the two pointers method over here. So I have, let's say, a string, and this string will be now converted to an array, and I'll point it from here, the two pointers, the left and the right as well, and I will try to match every single character. So character with the pointer of left should be equal to right, and if not, okay, so this will actually keep moving, but if not, break. So break is essentially you are going to return, let's say, false, because all the words that are in the palindrome should match. So something like this, let's say A, B, B, A. So this is a valid palindrome, okay? But let's say A, B, C and A, this is not a valid palindrome. So this is the way it works. Now let us write some code for it. So I'll try it on the VS Code itself. And here now let us start by making a new file. So let us say valid palindrome.py. Okay, so this is class solution. Let me increase the font for you. Okay, so class solution, and it is a function, let's say, is palindrome. With a string, it takes a string and returns out a bool. Now we have to work with this using the two pointers. So like I said, we will have a start and end, let's say 0, and the length of the string itself, -1 basically. Okay, so this is the way we start, and I'll say while start is less than end, I want to perform something on it. And if let's say my string start is not basically equal to the end, okay, so in the two pointers I'm going to then return the false. And meanwhile, if both are true, I'm going to increment as well as decrement the pointer till the time they meet each other, and the initial case will be returned true. Okay, so we are done with the code, and now we can also test this. So I'll say if underscore name is underscore main, I want to perform something. So in this case, S, let's say, stays for solution, or let's say SOL for the solution. So I'm making an object of my class, and now I'm going to print with, let's say, is palindrome. So from SOL dot is palindrome, I'm going to, let's say, give it a string. So let's say AB, let's say AVVA, something like that. So this is a valid palindrome. And now let us try to run this. So over here, I have to say Python space valid palindrome, and it says true. And now if I mess something over here, let's say EVBA, something like that, I'm going to run it again, it says false. But now this is not going to work. The reason is, if we look at the Leetcode problem, it says a phrase is a palindrome and all and everything. But if you see over here, there are spaces, there are symbols. Okay, so you have to get rid of this. Okay, so it says S consists only of printed ASCII characters. Apart from that, you need to have everything in lowercase. That is first thing. Second thing is, you need not have any space or special characters in that. So we have to now pre-process that string. Otherwise, it is not going to work. So the process starts over here. I will say, let's say, input string, which is the best way to put it. And let's say join, and I'll write something, let's say character for character. So this is a way of writing. So character for character in, let's say, string, if the character is an alphanumeric value, so which is alnum, or I think it is alnum. Yes, is alnum. Okay, so this is the way you actually say it. So only if the character is alpha numerical, I am going to append it. Otherwise, everything else is going to get rejected. And also you will have to say input string needs to be lower, because obviously the cases are also managed where you cannot have any uppercase variable. So here again I'll have to say input string dot lower. Okay, so now we are done with the pre-processing, but now we will have to make changes accordingly. So now S is not functional anymore. So here there will be input string. Apart from that, wherever there is S, there will be input string. Okay, and now let us try to run this. So it says false. Now let us take the example from here itself: a man, a plan, a kennel, and then Panama. And let us paste it over here. And now let us try to run this. It says true. Now it basically works. So now if we take this solution and paste it in the Leetcode and try to run it, it runs. And now click on submit. It is done. Okay, so it says beats 88% of the Python users. Memory is not efficient, but we will look at that in some other tutorial. Now let us look at the another type of a problem. So now there is one easy problem and there is one medium problem. So let us start with the easy problem. So I think the problem is basically understanding the price of the stock. Okay, so this is the new problem, which is best time to buy and sell the stock. So it says, I will give you an example. If we look at this array, okay, so I will draw it using the representation, then you will have a better intuition of it. So let's say problem 2. So this is best time to buy and sell stock. Okay, so there is an array as an input, and let us take the same values of the array itself, which are essentially 7, 1, 5, 3, 6, 4. Okay, so 7, 1, 5, 3, 6, and 4. And now you have to return where you have to buy in such an angle that it will be the lowest price. Because if you look at the concept and theory, let's say these are all the points that are given to you. Okay, so the highest number is 7, so let us take 7 points. Let me make a bigger diagram for your intuition. Okay, so bigger graph, something like this. So let's say 1, 2, 3, 4, 5, 6, and let's say 7 over here. Now it says that let us assume that the stock is moving, and what they want is you to buy at a particular point where you will have the greatest yield. Okay, so the basic theory is that you buy at lowest and sell at highest, which is a basic notion behind this. Okay, so this is basically your profit. Okay, you have to look for profit as much as you can. Let's say it starts from 7, so let us draw these points. Okay, so 7, 1, and then it is 5, and then 3, and then 6, and let's say the last point is 4, something like that. Okay, so significantly this moves in a straight direction, but now you want to buy at such a lower point and sell at such a higher point that you will be able to make the highest profit. Let us say you plan on buying over here, okay, at specifically at this area. This is the highest price and no other prices have been reached till here. So it is a loss for you, because if you buy over here and it goes like this, you are in the loss. Your plan is to buy at the lowest. Okay, so let us say the lowest point over here is 1. So let's say if you buy over here and then it again bumps up to, let's say, 5 over here, At this point of time, your profit is essentially going to be 4. Why? Because 5 minus 1. You bought at 1 and you sold it at 5. Okay, so let us store this value somewhere in a variable. Let's say we will call it profit. And let's say it stores 4. Then from 4 you are again going to monitor. It is at 5 and it dips down to 3. In such a case, there is a loss, okay, because it is lower. But it is not the lowest value. You also have to check for the lowest value. The lower value at till now is 1. Lower is 1. So if any other value that is less than 1, you are going to update it. If the profit is higher, you are going to update it. So this is the way you are going to pursue the problem. At 3, at this point of time, no, we are in the loss. And it's still not the lowest point. Then it again climbs up over here, which is essentially 6. So still your lower is 1. So your profit now is going to be 5. So 4 will be cancelled out, 5 will be stored. Again it dips down to, let's say, 4 over here. You are in the loss. Is it a lowest point? It is not lowest point. So starting right from the lowest point, which was essentially this, and you move all the way to the 6, you have the highest yield, which is essentially 5. And now if you check at the example over here, it says that when you feed such an array, your output is 5. Now this kind of a problem can be solved using the 2-pointer method. So the way we do it, you will start with a left pointer at the phase 1 for the point 1. So let's say again it was 7, somewhere here 1, and then it was, I think, 5, somewhere over here, then 3, 6, and let's say 4. Okay, so you start one pointer left over here and another pointer right over here, and now you are going to move the right pointer till the end of your array. Okay, you are going to move it till the end of the array. Now this pointer is essentially going to check whether it is the lowest point. If it is, we are going to update it. And you will also monitor the profit. So every single time you are going to subtract a significant value from the left and right to check if that is greater than the current profit, and you are going to update it. So now let us look at the script of it. Let us do it over Leetcode. Okay, so this is now new problem. Okay, and here now I'll just copy this like this, and now let me make a change over here. So the prices is essentially your list. Now first thing is start by making a left and right pointer. So let's say starts from 0 and right pointer starts from 1. This is the first thing. You will also require a variable that is maximum profit to store. So let us start with 0. Now while the right pointer is less than the length of my array. Okay, while it is less than the because it is not starting from end, we are not going to check the crossing of left and right pointer. We are going to check, we have to start from the right pointer till it reaches the end. That is my goal right now. So if the prices, that is my array, with the left is, let's say, lesser than the prices of my right, I want to perform something. In such a scenario, I'll make a new variable which is, let's say, current profit, and I'm going to say prices of the right minus the prices of the left. So this is going to be our current profit. Okay, now try to understand this. If the price on the left is less, okay, if we look at this example itself, the price on the left is less, for example this point, and so let me make it L. So let's say this is L and this is R. Since this is a lower point, the price on the left is less than the point than the price on the right. In such a scenario, I'm going to subtract it like we did to find the current profit. And then we are going to check it with the maximum profit. In such a scenario, if my maximum profit is lesser, we will update with the maximum profit. So current profit works in the real time when the two pointers are moving with each other, and the storage will be done by the max profit. Okay, so this is the way you approach this problem. So only and only when the price on the left is less than the price on the right, I want to take action. Otherwise, I'm not going to do anything. So in such a scenario, now I will update the max profit. It is maximum profit, let's say. Okay, so I will update the maximum profit where I check for the max value of the two. So maximum profit as well as my current profit, whichever is greater will be updated. Else if the price on the left if not less than the right, I have to make the left pointer to the right. I'll make it point, and irrespective of everything, the right pointer will be always incremented, because if we look over here, the right pointer needs to keep moving. But if the price on the left is, say, over here, this is a higher one, in such a scenario, I'm going to turn the left pointer into the right, and I'm going to increment the right irrespective. Okay, so this will be a left pointer because you have found the highest price till now and you haven't found any lower price. So I don't have a reason to stay over here. I can check my condition accordingly. So that is something is happening over here, and now in the end I'm going to return the maximum profit. Okay, so now let us make an entry point for this. Main, and let's say solve for solution. So I'm making essentially an object of my class, and now this takes an. So we will take this same example, which was basically 7, 1, and I think later on it was 5, 3, 4, 6. So 5, 3, 4 and 6. Okay, and now I'm going to print the maximum profit. So let's say max profit itself, and sol, which is your object dot max profit. It takes prices as an input, and then it will return the max prof. So let us run this. So now pi, best time to sell and buy stock, it is 5. So now let us copy this that we have typed till now and try to put it in our Leetcode. Run it and check if it is true. Yes, it is true. Now press submit. Okay, so it beats 81% of the Python users, and it is also space compliant. And now finally I would like to cover one medium problem. Obviously I'll give you some problems to work with, okay, which will be typically mixed questions. Okay, so now let us look at something known as 2 sum 2. Okay, so this is 2 sum 2. The first thing that I actually showed you, the example over here, to understand the concept of the two pointers itself. Okay, so this one, that we have to check for the addition of the two pointers, and we have to also check how it turns out to be. So here now we return the indexes. So you will be given a sorted array, that is first thing, and you will be given a template. You have to return the numbers in such a manner that the indexes, and they are starting from 1. Okay, so index starts from 1, so keep that in mind. We will write code for that, not an issue. So indexes start, so we will check in the sorted. So this is a typical two pointer solution. Okay, so let us now write something about it. So let's say this is your problem 3. Let me use a different color. Okay, so problem 3, and problem 3 is basically 2 sum 2. Okay, so 2 sum earlier you have seen, which was not also, I would say, appropriately optimized solution. You will learn it in hash maps, but for now this is 2 sum 2 where you are given a sorted array. So in order to solve this, let's say you will be given an array, so it will be a sorted array. So let us start with 2, 5, 7, something like our example, and there will be a target, and target, let us say, is 9, something like that. Okay, So 9 will be available. In such a scenario, you have to start from the left and the right pointer. So start and end. And essentially you are going to work with this the way you have to check for the addition. So in the array of, let's say, start plus array of end, you are going to check if those values are equal to your target. If yes, you are going to return the indexes with added 1 because the indexes are starting from 1. So s plus 1 and n plus 1. That is the way they are expecting the output. If not, if this is essentially greater than the target, in such a scenario you have to take a different step, obviously. So then you are going to move your end pointer, obviously, because let me erase this. Obviously, because if the end is very high, it is no use of looking for the number greater than that, because since the array is sorted, if let's say it is 2 plus 11 and if I add, the number is going to be higher than the target. In such a scenario, I have to move to the end pointer. So I'll decrement the end pointer by 1, else the finally condition will be start will be incremented by 1. So essentially this condition is when your addition is lesser than the target. Okay, so this is the way we solve it. So now let us write some code for it. So starting over here, so I'll make a new file over here. Okay, so let us start with, let's say, class solution, or we will just copy this. Okay, and there is a numbers array, which is essentially your list, and then there is target int, and it also returns a list. So start by making two pointers, start and end. Start starts from 0, end is basically your length of the numbers minus 1. And while this start is less than the end, I want to perform something. So if the numbers with the start plus numbers, which is essentially your array, with the end are equal to the target, I want to perform something. So in such a scenario, I am going to, let's say, return start plus 1 because they are expecting indexes. Now, else if, let's say, the numbers with the start plus numbers with the end are greater than the target, we are going to decrement the pointer, like we said. Else, in the final condition, we are going to increment the pointer. And let us write a base condition for this. So let's say return of minus 1 and minus 1. Okay, so this is the way it happens. Now let's look at entry point. I hope now you might have got some idea about the two pointers. So now let us write SOL, which is an object for my solution. And over here, let's say, let us make an array. Let us say numbers is equal to, we will take the same example, which is 2, 7, 11 and 15. 2, 7, 11 and 15, and the target they have given is like 9. And now I'm going to print whatever the value that is coming. So let's say outcome, which is going to be your list. So SOL, the object, followed by toSum, takes numbers and target as their respective inputs, and I'm going to now print the outcome. Okay, so let us now run this. So pi followed by toSum, it is 1 and 2, and we have it. So now let us copy this code. So this is a typical two pointer solution. Now run it, submit it, and we have it. Okay, so this is the way it is done. So two pointers is very important, and I hope you might have learned something or the other. So okay, so we basically started with the concept. I will actually share this whiteboard with you so that you can look forward to this, the way we have covered the things till now. Okay, so in the next tutorial even, I don't know what we will be covering. Most likely I believe we are going to cover let's say something like hash maps or something like that, a new data structure essentially. Okay, so and I'll also share all of these respective files with you. Okay, so the link to the entire GitHub repo of the 2 pointers will be given below, which will include the whiteboard stuff, all of the files, as well as the Leetcode links. And I will also share one practice problems file with you. So you can just click on the links and directly head to the problems and practice the 2 pointers. It is a very, very important concept. Okay, most of the time it is asked in many companies, even in the very big companies, big giants, tech giants also look for such easy kind of concept. Since people don't know concept, they don't know the solution, and they believe that it is very hard to ace such kind of problem. But if you just have the notion of how the things are working, it is very easy for you. Okay, so I hope you might have learned something or the other. We will today stop here for now. Okay, so in the next tutorial, we will look at some new concept, like I said. Okay, so and if you like my content, please do subscribe to my YouTube channel and share the video with the people who are willing to learn something or the other. Okay, so until next time. So thank you for watching. Goodbye.